So let's look at problem 4. Problem 4 is asking the same thing as problem 3 is, which is to graph the equation. Now in this case, it's pretty straightforward. You can actually do this one of two ways, and since I did the first one using the slope-intercept form, I'm going to actually do this one a different way. In this case, we have 2x plus y equals 3, and I could possibly solve this using the xy table method, which is essentially plug in a value for x and see what you get for y. So here I'm going to just choose 0 for x. If I choose 0 for x, what I like to do is just write it to the side, x equals 0, and then write the equation and plug in a 0 wherever I see an x. Now you'll see that I'm left with only one variable now. I started with an equation with two variables, but because I assumed that x was 0, I only have one variable left. So here, this becomes 0, sorry about that, plus y equals 3, and this boils down to y equals 3. So when x is 0, y is 3. Well, what happens if y is 0? Let's find out. So if y is 0, we get 2x plus 0 equals 3, which boils down to 2x equals 3, x equals 3 over 2. Well, let's say we pick another number just to be, just to be fancy. Let's pick x equals 4. If x is 4, then y is going to be 2 times 4 plus y equals 3. 8 plus y equals 3. Y is going to equal -5. So you can see we don't have to just pick zeros, we can pick other numbers as well. But 0 sometimes works nicely. We could pick a 1, just to, x equals 1. If x equals 1, then y is going to equal 2 times 1 plus y equals 3. 2 plus y equals 3. Y equals 1. So if x is 1, y is 1. So now let's just plot some of these on the coordinate plane. So if x is 0, y is 3. That would put us right here. If x is, let's not do the fraction. If x is 4, y is -5. So 1, 2, 3, I go out 4 on the x coordinate and then down. We actually don't have a point there, but we can just kind of pretend like we did. If x is 1, y is 1. That puts us right here. And you can see that a line is starting to emerge here, and that would be the line right there.